Hi, I'm Lyle Stevick, and this is how to make a 3D printer table. The 3D printed bracket that holds the table together is drawn in FreeCAD version 1.0.1. The FreeCAD drawing is divided into 4 segments. As the drawing goes in the background, there will be some commentary on the drawing, also on the woodworking involved, the slicer and printer settings, also on decorating printed parts with 2-part epoxy and glitter. Since brushes can't be saved after using epoxy, several parts are finished at once. The starting point of the drawing is where the table leg fits the bracket. This is a nominal size 1x3 with an actual size of 0.75 inch by 2.5 inch, or 19 by 63.5 millimeters. Since the leg is on a 10-degree angle, we add 1 millimeter to the length, and print spread adds to the width. The final size that actually fits the leg I'm using is 20.5 by 64.5 millimeters. Your conditions may be different. It's always a good idea to check the fit on the first part, and that includes the hardware. The hardware involved in this project includes 1/4 by 1 inch lag screws for holding brackets to the table, 3/8 by 1.5 inch lag screws with fender washers for holding the wheels to the table, and 1/4 by 1 3/4 inch hex bolts with washers and nuts to bolt the legs to the brackets. The leg screws are zinc coated steel and the hex bolts are stainless. Normally, I try not to mix hardware like that, but there were some pricing availability issues. This project also was done without much in the way of planning. Sometimes great for creativity, sometimes a challenge to keep up with on making everything fit and match. Print orientation is important for brackets. When printed with a base on the print bed, the stress from the leg only needs to separate layers to break the part. Printed on end, the stress has to break the filament and the carbon fiber. Printing on end is important for many brackets. This solid bracket is used to join aluminum flat bar. This is a bookshelf bracket. Since the bracket is being printed on end, the end face needs to be preserved as one continuous plane. I'm doing that by patting the first drawing, the bracket base, downwards, and the second drawing, the leg, upwards, putting the two drawings in the exact same plane. Sometimes the order of steps in FreeCAD is so important. Doing it in a different order can cause error messages, unconstrained parts, or parts that just disappear from the screen. Each of these 4 drawings in the video are uncut and played at the speed they were drawn. If you get stuck, look closely at the drawing in the video and follow the steps exactly. This is especially true when connecting the continuous arcs. There are several construction lines on the drawing going through the arc centers and at 30 degrees. Sometimes they are labeled as 30, sometimes as 150. It's the same angle, and that's just one of the many things about FreeCAD I haven't figured out yet. These lines are used to make a parametric model of a smooth continuous arc out of 3 arcs. Just like when drawing the outer wall of a hand drum, the way to make a continuous arc between 2 arcs is to put the center point of both arcs on the same construction line and have the arcs meet on the construction line. Doing it to 3 arcs, or like with a hand drum to 7 arcs, is no different. The part will mostly have a 4mm wall thickness, so the downward pad is 4mm. The 10-degree angle is obtained by clicking custom direction and going 0.15 in the Y direction and 0.85 in the Z direction. The leg will be padded upwards at the same angle. The 1x3 leg pieces are cut 10 degrees at each end, same direction, and 21.5 inches long. This leaves a table height of almost 30 inches, just right for the Neptune 4 Max the table is made for. My miter saw doesn't really have a 10-degree mark, so I made a few cuts to dial it in, holding it in a printed bracket after each cut to check. Once dialed in, I tightened the saw, double checked one more time with a cut, then cut all 4 legs the same length. The 4 pieces are then placed in parallel under the table to make a clean cut all the way through the table. The table is a birch butcher block countertop from Home Depot. It was 75 inches long, 25 inches wide, and 1.5 inches thick. In order to cut it in half, first I measured very carefully from both ends of the short side to the middle, then drew a line where it was to be cut. Adjusting for the width of my saw fence, I clamped a cut guide to both ends of the table. The cut was made with a heavy-duty Makita hypoid saw with a fine-tooth Freud blade capable of cutting aluminum. I've cut tabletops before with a much lighter-duty saw. It can be done slow and steady, but if I had to do it over, I would definitely get the hypoid. After cutting the butcher block in half, a birch 1x2 trim piece is attached to the cut edge, both top and bottom. After all pieces are cut, a palm sander is used on all the pieces, and this is when we make sure the trim pieces are finished flush with the butcher block. After using 100 grit sandpaper, the pieces are sanded again with 220 grit sandpaper. The dust is wiped off, then all the pieces are stained with golden oak wood stain. After the stain has dried overnight, the wood pieces are ready for assembly. The brackets are coated with 2-part epoxy with glitter sprinkled over the first coat. The second coat will mostly lock the glitter in place. And the parts in this video got 3 coats of epoxy. After the last coat of epoxy, the brackets are also ready for assembly. To start assembly, I measure in from the long edge at each corner about 2 inches or 50 millimeters and make a mark at each corner. Using a straight edge, I draw 2 diagonals. Then, measured in about 38 millimeters from the short edge, make a mark on the diagonal at all 4 corners. The brackets are then centered on the diagonal 38 millimeters from the short edge. The brackets are attached to the butcher block with 1/4 by 1 inch screws. The holes are marked and drilled first with a 3/16 inch drill bit. After all the bracket screws are tightened to the table, then the legs are placed in the brackets, marked, taken out, drilled with a 1/4-inch drill bit, reinserted and bolted with 1 3/4-inch hex bolts. Once those bolts are tightened, it should be rigid enough to turn upside down and place on top of the second piece of butcher block. Make sure and draw the diagonals on that piece first. The butcher block does have a top and a bottom. The bottom has knots and wood filler. The top side doesn't. If that's important to you, pay attention to which side is up when you draw the diagonals. If it's not important, you can just take the printer off once in a while to show people what not to do. After positioning the legs on the second piece, centered on the diagonal and equal distance from the edge, use a square to verify that the butcher block pieces are centered over each other. Repeat the process with the second set of brackets. Drill, attach, and tighten to the table first. Drill, attach, and tighten to the legs second. While the table is still upside down, the wheels are attached with 3/8 by 1.5 inch screws with fender washers. After assembly, the entire table, including the brackets, is coated with semi-gloss polyurethane. In between coats, the finish is gently sanded, hand sanded, not with the palm sander, with the grain using 220 grit sandpaper, then wiped clean with a lint-free cloth or a tack cloth, then recoated. This got 5 coats of polyurethane. The printer used for this project is an Elegoo Neptune 4 Max with a Micro Swiss high flow hot end and a Micro Swiss 1mm nozzle. The filament is carbon fiber polycarbonate, printed at 266 degrees. The slicer is Cura Ultimaker 5.10. The layer height is 0.32 millimeters. The wall line count is 50 to avoid infill. The brim line count is 15. The print speed is set at 70 millimeters per second. That prints at 35 on one outer wall, 56 on the other, and 70 on lines in between, for a ballpark average of 50 millimeters per second. Combined with the 0.32 millimeter layer height and the 1 millimeter nozzle diameter, this is a volumetric flow rate of about 16 cubic millimeters per second. The print bed is at 70 and well coated with Magicoo. This is listed for PLA, but works well on the textured side of this for this printer using carbon PC. The printer head is leveled about 0.04 millimeters lower than for PLA printing, I think. The fan is turned off. The fan is a big feature for this machine, but is used for Hyper PLA, something I haven't tried yet. The filament is dried first at 65 degrees for 4 hours. Support is avoided by use of chamfers and angles. Overhangs are limited to about 30 degrees. I am new to a lot of this stuff, so positive, helpful comments are welcome, and if you are inspired to make something, post a picture in the replies. The bracket, along with several other parts, is ready for epoxy. The brushes can't be saved afterwards, so parts are done in batches. This table project was shoot from the hip. totally unplanned. It started with, I need a higher volumetric flow rate for printing my drums. Some of them were 20-hour prints. I saved up for a more expensive printer, then did some research and ended up buying a much less expensive printer with a high flow hot end. This left me way under budget, so I splurged on a few things, like the high-powered power saw and the 4-inch wheels with the 2,600-pound load rating from Amazon. The table came out beautiful. There are still some things I would do differently. The bolt here is 2 millimeters short. So in this video, I reduced the pad around the bolt from 4 millimeters to 3 millimeters. This fits just right, one thread showing. It can't be overemphasized. Have the hardware in hand and check the fit as soon as possible. Secondly, I've changed the position of one of the leg bolts. Without the leg inserted, the holes look centered. They are centered on the bracket, but not on the leg. This wall is 6 millimeters thick. The hole gets moved over 6 millimeters, and a straight 6 millimeter line is used to connect the two arcs. This makes the holes centered on the leg, and again, this is the version in the video. Finally, if I had to do it over, would I put the top on face up? Yeah, probably. But considering the footprint of the printer, maybe not. My use of two-part epoxy started as a water sealing effort for flower vases. An upside-down flower vase is similar in shape to a hand drum, but with a way less expensive learning curve when it comes to learning how to print them. The thing is, a flower vase needs to hold water, and none of them did. After coating with two-part epoxy, they all did. I started by adding white epoxy additive. Regular paint can't be added to epoxy. After a few projects, I found that clear with glitter sprinkled into it looks the way I like it. There are exceptions. This table bracket set used white in the first coat with a lot of fine glitter sprinkled over that, and then 2 more coats, then 5 coats of polyurethane. This was to match wood with golden oak stain. This brings up an important consideration for parts like drum bodies. White can enhance the visibility of the vertical seam. Clear can reduce the visibility of it. This epoxy is available on Amazon and comes with warnings about overstirring and creating bubbles. That applies to solid epoxy parts like putting a flower in a cube of epoxy. I've never had epoxy bubbles stay in a brushed surface. However, bristles can come off the brush as epoxy does put a lot of drag on the brush. It also tends to sag if put on too thick, so spread it well. The drums being epoxied have green rope, blue rope, and silver hardware. The glitter used is green and silver for all the small parts to the drum stand and the flower vase. Then silver, green, gold, and a little red were added to the mix for the drums with a green rope. Then to what was left of that mix, I added several types of blue and more silver and gold for the drum with the blue rope. Here's a preview of my next project. I have 3 drums with the same size drum head, a 6 3/4 inch bongo head. They each have different body shapes, and that produces a different sound for each drum. On my next project, I want to use another 6 3/4 inch bongo head with a top that's much more bowl shaped than my other drums. I'm hoping to get a deeper, more resonant sound out of this drum. I've also made a change to the ring that holds the drum head. I've used 24 slots instead of the 48 holes I was using. So between making a drum with a larger volume, hopefully with a more resonant sound, and switching to 24 slots, that is what I hope to be my next project. The drawing is coming to a close. There's about a minute and a half left. Thank you for watching. Thank you to the local drumming community, to Daniel Ide and everyone else at the Fallbrook Drum Circle. Thank you to the FreeCAD community. You're where I learned all my FreeCAD. If you can watch me draw to a metronome for 20 minutes, you can do anything. I hope you all enjoyed the video.